Good morning, students. So, first of all, am I clearly audible and visible? Yes. So, yesterday we were doing our chapter number 15, that was Nina's birthday. Right? We did half of the questions earlier, that is from question number 1 to question number 6. Right? So, today we are going to continue that and then we will start our new chapter. That will be Rama's kitchen. It is first we will continue with the chapter 15, that was Nina's birthday. We were talking about area and perimeter. So before starting, let me summarize to you what we are going to see in the video or in the live. I hope you all will stay active in the chat box. So the things we did yesterday was area and perimeter, about different shapes, that is square and rectangle. When we talk about the perimeter of any shape, it is only the outer boundary of that shape, right? So when we are talking about the outer boundary, it is the perimeter. And when we are talking about the complete space within the shape, that is complete space inside the shape, that is called the area. When we conclude that this is the perimeter, we use the units like meter or centimeter respectively. But when we are concluding the area of the shape, whether it is square, rectangle or any other shape, the units we use are meter square, centimeter square and so on. So shall we start? Fine. Let's see the first question. A rectangle has a perimeter of 100 centimeter. Perimeter of the rectangle is already given to us. We have to make sure that we remember that which shape we are talking about and what is the perimeter of the shape. We have been given the perimeter and not the area. Remember this. If the length is 30 centimeter, right? Length is 30 centimeter and what is its width? What will be its width? Also find the area of the rectangle. Also we have to find the perimeter of the rectangle has been given to us. I am again saying stay active in the live chat box. We have been given perimeter of the rectangle, that is 100 centimeter. So can you tell me the formula for the perimeter of the rectangle? What is the formula for perimeter of rectangle? Do you all know? What is the formula for perimeter of rectangle? It is 2 multiplied by length plus breadth. 2 multiplied by length plus breadth. We have been given that the length is given to us, it is 30 centimeter. We have to find the breadth. Now I have to tell you something, that breadth and width both are the same thing. Breadth and width both are the same thing. That is the part of the rectangle. Like this is a rectangle, the opposite sides are equal. This is the length, this is also the length. And if I am talking about this, it is breadth, it is also known as width. Right? So what is here? 2 multiplied by L plus B. We have been given L and we have to find breadth. So we can put the value of length in the question, that is 2 multiplied by length is what? 30 plus B, that is breadth. And here we have to write equals 100. Why? Because we have been given the perimeter already, that is 100. So next 100 equals 2 multiplied by 30. 2 multiplied by 30 is what? 3 2s are 6 and 1 0, that is 60 plus 2 times of the breadth. So what is here? It is 2b equals 100 minus 60. 2b equals 40. And then breadth is equals to 40 divided by 2. 40 divided by 2, what is the meaning of 40 divided by 2? Can you tell me? 40 divided by 2 will be, yes, 40 divided by 2 will be 20 centimeter. So breadth is 20 centimeter. Next, what do we have to find? We have to find the area of the rectangle. So area equals length multiplied by breadth. Length is 30 and breadth is 20. So 30 multiplied by 20, this will be 3 2s are 6 and 2 zeros are here. We will put 2 zeros here and it will be centimeter square. Centimeter square. So when it is centimeter square, when we are calculating the area. Fine. Should I move to the next question? Okay, let's move to the next question. In a figure given below, a rectangle of 4 centimeter length and 6 centimeter width is shown. If a square piece is cut out, what will be the perimeter of the remaining area? So before that, we will draw the figure. This is the figure. And we have one rectangle cut here, right? What is it given? That it is 8 centimeters. This is 8 centimeter and this one, the rectangle is 4 centimeter in length. So this is 4 centimeter. This is also 4 centimeter because the opposite sides of the rectangle are equal. And what do we have here? 6 centimeter in width. So this is 6 centimeter and this is also 6 centimeter. Now the question is, we have to find the perimeter of the remaining shape. Means इस रेक्टेंगल में से सॉरी इस स्क्वायर पीस में से जब हम इस रेक्टेंगल को कट कर देते हैं, when we remove this rectangle piece from the square piece, what is the perimeter of the remaining one, right? So when we talk about it, it is the sum of all sides, right? So perimeter is what? Perimeter is sum of all sides. Perimeter is sum of all sides and we have to find the perimeter of this shape. Leaving this rectangle here, right? So when we have said that this is a square, so all the sides must be equal. This is 8 centimeter. This should also be 8 centimeter. So first is this side is done. Then some of the other side, this side is also done. These two sides are done, right? This is 8, this is also 8. And what is this much? This much is 8 minus 6. 8 minus 6, that will be 2. Right? And this is, we have already been given, this is 4. So it will be plus 2 plus 4 plus, now this one, this is also 6. It has been given to us. This is 4 and this total is 8. So it will be subtracted from this much. This is what? This will be also 4 plus 4. Now we have the perimeter of the remaining shape, right? So it is 8 plus 8, that is 16, plus 2 plus 4, 6 plus 6 plus 4. Now what do we have here? 16 plus 12 plus 4. We can add it. 6 plus 2, 8 plus 4, 12, 2, 1 carry, 1, 1, 2 and 1, 3. 32 centimeter. The answer is 32 centimeter is the perimeter. Am I clear? Okay, let's move ahead. See the next question. The floor is 10 meters of a classroom is 10 meters long and 6 meters wide. The floor of a classroom is 10 meters long and 6 meters wide. How many square tiles of size 1 meter into 1 meter is needed to cover it completely? So first we have to find the how many square tiles of size 1 meter into 1 meter are needed to cover it completely? So because we have to find the area of classroom, then we will find the area of tile. Area of classroom will be, what is the shape of the classroom? It is rectangle. The floor of the classroom shape is rectangle in shape, and the area of rectangle is length multiplied by breadth, or we can say length multiplied by width. What is the length? Length is 10 meters. And what is the breadth? It is 6 meters. So 10 multiplied by 6, that is 60 meter square. Now we have to find the area of the square tiles. So when we are talking about the area of square tiles, we have to first see the shape of this one. So what is the shape? It has been given to us 1 meter into 1 meter. 1 meter into 1 meter means the length is same and the breadth is same. If both of the measurements or dimensions are same, the shape must be square. So area of square tile. Square tile is side into side. That is 1 into 1, which is 1 meter square. So when it is 1 meter square, what we will do? We will divide both of these. That is 60 divided by 1. And we know whenever we divide any number by 1, the answer remains the same. So how many tiles are needed? 60 tiles are needed to cover the floor. I hope I'm clear that how many tiles we have to get to cover the classroom floor. When the length is 10 meters and the width is 6 meters, we have to find 60 such tiles to cover it completely. Fine. Let's move ahead. Find the area of the shaded portion in the given shape. So our first shape is this one. Our first shape is this, and this is the shaded portion. Right? This is the shaded portion. And the measurements are, this is 3 centimeter, this is 3 centimeter, and this is 2 centimeter. Now what we have to do, we have to find the area of this shaded portion. This shaded portion we have to find, and if we look closely, the shaded portion is in the shape of a triangle. So we have to find the area of a triangle. There is a formula for the area of triangle, that is 1 upon 2 multiplied by base multiplied by height, but you don't need to summarize all that. We can see clearly that in this rectangle, there is a diagonal. What is diagonal? The line that joins the two opposite sides or opposite angles. That is the diagonal. So when we have a diagonal, it divides the rectangle into two equal parts. Right? When it is dividing it into two equal parts, what will we do? We can simply find the area of the whole rectangle, and then we will divide it by 2. We will do half of it. So what is the area of rectangle? Area of rectangle is length multiplied by breadth. That is 3 into 2. 3 twos are 6. So 6 centimeters square, it is the area of the rectangle. When we are saying that we have to find it of the shaded portion. So what will we do? Area of shaded portion, that is 6 divided by 2. Means how many times does 6 come in the table of 2? It comes 3 times. So the answer is 3 centimeter square. This is the area of the shaded portion. I hope I am clear. Next is the square. And what has been given? We have been given the size 25 centimeter and 25 centimeter. We have to find the area of the shaded portion, and it is completely shaded. This means that we have to find the area of a square. Why is it a square? Because all the sides of a square are equal. And when all the sides of the square are equal, so it is a square, we have to use the formula for the area of square. And the formula for area of square is side multiplied by side. Side into side. We have the side measurement, that is 25, and another is also 25. So you will solve this. Whatever the answer comes, that will come here, and it will be centimeter square. This much, at least you have to do it yourself. Okay, it is meter, so you have to write here 25 meter square. 25 meter square. 25 multiplied by 25, that is whatever the answer will be, you have to solve it and tell me the answer, right? So let's move ahead. This is our next chapter, chapter number 16, that is Rama's kitchen. When we talk about the new chapter, what do we have to see here? We have to see the different shapes, that are 2D shapes, 3D shapes, and their nets, how to make them in real life, and the rolling and tumbling objects. What is the meaning of rolling and tumbling objects? Rolling and tumbling objects means that when the objects are rotated in a certain degree, when they are moved in a certain degree, what is the change that occurs in them? This we will study in the new chapter. Okay, let me quickly summarize what we are going to study in this chapter, new chapter, that is maps. First of all, we will study about 2D objects, 3D objects, that are 2D shapes and 3D shapes. And we will talk about rolling and tumbling shapes. Means when the objects or when the shapes are moved or rotated from one degree to another degree, what are the changes that will occur in the shape or in the letters, whatever it is. Okay, so when we are talking about 2D or 3D objects, you all have already studied about 2D and 3D objects in your previous classes. So 2D objects are the objects or the shapes that we draw in our pages, in our books. It doesn't have a height. It has a length, it has a breadth, but it doesn't have height. That's why it is a 2D shape. When it is a 2D shape, it can be rectangle, square, circle, triangle, anything like that. And when we are coming to the 3D shape, 3D shapes are what? The shapes which have a height. The shapes which have height are known as 3D shapes. For example, cube, cuboid, cylinder, sphere, cone. These are the examples of 3D shapes, right? So these 3D shapes are also made up of small, similar 2D shapes only. Like when we talk about the cube, it is in the real life we can find dice or Rubik's cube that we used to play with. So these shapes are made from what? 2D shape. This cube is made from small 2D shape, that is square. When we are talking about cuboid is made from 2D shape. Which one? That is rectangle. Fine. So let's see the first question. Among the following letters, find out which one would look same after half turn. So before moving to the question itself, first we will understand the meaning of half turn. What is the meaning of half turn? When I am saying that this is my object, just imagine this is an object and we have to turn it completely. Now turning means what? That it will move from here, rotate and come here again. This is called a complete turn. A complete turn also shows the particular angle, particular degree at which the shape is. So, what we have to do, we have to see that what is the total degree or total angle in it. So, what will it be? It will be, we have seen this is a complete angle, so it will be 360 degrees. One complete turn is equal to 360 degrees. We are talking about half turn. Half turn means we have to divide 360 into from 2. From 2, which means we have to do half of 360 degrees. So when we perform this function, what will be our answer? It will be, as you can see, 180 degrees. So half of 360 is 180 degrees. Half of 360 is 180 degrees. Now we know that half turn means 180 degrees rotation. Means this much is 180 degree. 180 degree is what? A straight angle. Straight angle means it can, if this is my object and we have to turn it to 180 degree, it will be, this point will go from here to here. This is the half turn when we are turning half. So first we have x. If we rotate this x from its original position to half turn, it will turn to, simply it will remain the same. So it will remain same. Next we can see what will be the next one? H. If we rotate h, okay, if we rotate h, it will also remain the same. But if we rotate a, see, this is A. If we rotate it this much, what will it become? It will turn like this. And is it the same? It is not the same. Okay, yes, Nehan, good morning. So, when we turn any half turn, it will be half of it, that will be, it will not be the same to the original position. Is it the same? It is not the same. So, it is not considered the same letter. Next one, N. If we rotate N, this is N. If we rotate it from this to this, it will become this. It is still the same, right? So N is also the same in the half turn. B, if we rotate B from the original position to the half turn, it will become like this. It will not remain the same. So it is also not. O, O is a circle. So in circle, what happens? No matter at what degree you rotate it, it will remain the same. It will remain as it is, and it will turn the same. J, if you turn J from its position to half turn, it will become like this, and it will not remain the same. I will also remain the same, D will not remain, and S will also not remain the same, right? So we have to imagine what is this chapter about. The chapter is about the concepts of imagining that what is a turn, and when the objects are turned in a particular way, what is the actual matter that is happening? Do they remain the same or do they change? Okay, fine. Let's move to the next question. Identify the given objects and write the name of their 3D shapes. First is the matchbox. Can you tell me what is the shape of a matchbox when we see it? You all have seen a matchbox, right? So what is the shape of that 3D shape of that matchbox? Yes, Nehan, tell me. You are here, right? When we draw a matchbox, it looks something like this, if I'm not wrong, right? It looks like this. We have already seen it. You have seen matchbox, right? So how does it look? What is the shape? Okay, so the shape of the matchbox is cuboid. Cuboid is the shape of the matchbox. Next one is a plastic container. When we talk about a plastic container, we always talk about a circular plastic container. I know that there are other shapes of the plastic container as well, but we are talking only about this particular shape. And the shape of this plastic container is cylinder. Okay, next one is a football. When we see a football in a real life, it has some width or some density around it. It has some height. So it is not circle. What is the shape of a football? As it is 3D in nature, the shape of the football is sphere. Next is the joker's cap. Joker's cap looks something like this. There is something like this. So, what is the shape of the joker's cap? It is cone. So, it will be cone. And dice, we already have studied about it. I have already said in the previous things that dice, what is the shape of the dice? It is cube. Let's move to the next question, that is find the numbers which will look the same after uh, on a half turn. Now, what is the meaning of half turn here? Half turn, again, we know that a complete turn is moving from here, then again here. This is 360 degrees. And when we talk about half turn, it will go from here to here and then it will stop this much. So it will be 180 degrees. So when we turn 1, so it will remain will it remain the same? It will become like, when it is this, it will turn like this and it will become like this. So it will not be the same. Next is 2. When we do the half turn of 2, what will it become? It will become something like this, right? So it will also not remain the same. Next digit is 3. 3, if we rotate it half the turn, it will become something like this. It will also not remain the same. Next digit we have is 4. And when we rotate this half turn, give it a half turn, it will turn something like this. So it will not remain the same. Next one is 5. You can already comprehend that 5 will also change. It will not look the actually same. And when we are talking about 0, 0 is again in a circle format. Doesn't matter how much turn or how much degree you rotate any circle, it will remain the same. It will actually look the same. So 0 will be our answer, and 8, when we rotate 8, this is how we write it, and we are giving it half turn, so it will come here and it will become like this. So it will remain the same. 0 will 8 will also remain the same. So our answer is 0 and 8. 0 and 8 will remain same in after giving them half turn. Okay, let's move ahead. Explain the difference between 2D shape and 3D shape. This is an important question for you all, as you all should know that what are the difference between 2D shapes and 3D shapes. When we make a difference between 2D shape and 3D shape, first it's the difference of height. That there is no height in 2D shape and there is height in 3D shape. Right. Second will be their existence in real life. When we are talking about the existence in real life, that how does it exist in real life? When we are talking about 2D shapes, they doesn't actually exist in real life. Everything we see around ourselves, whether it is a bench, a pen, a laptop, a book, or anything, it exists because it has a height. It has some width to it. It has some weight. So 2D shapes don't really exist without the drawing we do. That is a different thing. But existence in real life is more of 3D shapes, not of the 2D shapes. And third will be our examples. And the examples, if we talk about the examples, I have already given a lot of examples. Still, I will repeat the examples. It will be, what will be the examples? It will be circle or triangle or square, rectangle. These are the examples of 2D shapes. And when we talk about 3D shapes, the examples will be cube, cuboid, sphere, cone, cylinder, and so on. Fine. Let's move ahead. How the following numbers are changed after half turn. Again, we know that the complete turn means an object goes from its initial position and comes back to the initial position. This forms the complete angle, and this is 360 degrees in nature. If it is 360 degree, then half of it should be half turn. Half turn means half of 360, and half of 360 is 180 degrees. When we are talking about 180 degrees, it is the straight angle. So we already have seen that one, when we write one like this, it doesn't change. It goes like it actually remains the same. Here we have seen that 8, 0 and 1, they will remain the same no matter the turn we are giving it. Like in half turn and in complete turn, they remain the same. So it will remain the same. These 8 will remain the same, and 1, 0, 1, 0, 1, it will also remain the same. So the answers will remain the same. It in itself, you have to remember the concept that what is the meaning of half turn, what is the meaning of complete turn. Half turn means 180 degree, that is a straight angle turn, and complete turn means 360 degree, that is complete turn of the shape. So the last one for today, write the order of rotational symmetry in the given shapes. Order of rotational symmetry means what? Means the objects or the places in the turn where it remains the same. For example, this is a rectangle. It has some length to it and it has some breadth. If I give it a half turn, right? If I give it a half turn, it will look like this, right? And if I turn it in, if I turn it more again, it will turn like this. Means how many times will it look the same? That is known as order of rotational symmetry. How many times while rotating it will come back to its original position? That is 2 times, 1 and 2. So the order of rotational symmetry is 2 in rectangle. When we are talking about circle, this is a circle. When we rotate a circle, no matter at what degree we rotate it, at what angle we rotate it, how much turns we give it, it will remain the same, right? When we will rotate it, it will remain the same. It will actually look the same like before. So the order of rotational symmetry in circle, it will be infinite. Infinite means that cannot be counted. It will be infinite. It cannot be counted. It will be rotated and it will look the same. Third one is pentagon. Pentagon is the shape of 5 sides. This is a pentagon, 1, 2, 3, 4, 5. How many sides it has? It has 5 sides. The shape with 5 sides is known as a pentagon. So when we rotate this pentagon, if this comes here like 1, it will look the same. Then 2, then 3, then 4, and then 5. Means how many times it can rotate and it will look the same. So we will rotate it 1 time, it will look the same. 2 times, it will look the same. 3, 4, and 5. That is how many by edge we will rotate it and it will look the same. So when we count it, it is 5. So the order of rotational symmetry in a pentagon is 5. Whereas when we are talking about a square, again, when we rotate it from edge to edge, if I rotate a square from edge to edge, it will remain the same, right? So the rotational symmetry, we can count it as 1 here, 2, 3, and 4. The rotation symmetry here is 4. Now triangle. Triangle can be of 3 types, whether depending on the measurement or dimensions of the sides. If all the 3 sides are equal, this is the ideal condition that we talk about, right? There are other different types also, like in isosceles triangle, 2 sides are same and the third one is different. In scalene triangle, all the 3 sides of the triangle is different. But when we have a simple uh, question, that is, what is the order of rotational symmetry of a triangle, then we will consider the ideal condition, that is the triangle we consider will be equilateral triangle. We will consider that all the sides of the triangle are equal. So this is a triangle. If we rotate it from one position to another position on the basis of its edges and all the sides are equal, it will look the same no matter what. So what will be the order of rotational symmetry in the triangle? It will be 3. And the remaining questions, that are the how to make a solid shape from a net. When we use a net and we make a solid shape from it, what is it? And how to make 3D shapes, what is the difference between 2D shape and 3D shape, and some of the exercises that has been given in your book that you have to complete it by yourself. Those are very easy questions. You have to just count the edges, count the vertices. Edges mean sides and vertices means corners. How many corners are there? How many edges are there? That is the different thing. So when we are talking, whatever we have talked today about, we have talked about chapter number 16, that is Rama's kitchen, and it considers 3D shapes, 2D shapes. What are the difference between the two? And half turn, complete turn. Complete turn means 360-degree. Complete angle, it rotates from the position and it comes back to the original position. That is the complete angle, that is 360 degrees. While when we are talking about half turn, it is rotated only half of the complete angle, that is 180 degree.